Welcome everybody. In the previous video, we looked at an interesting case of the other side of the properties of continued fraction. So essentially, we did such an exercise here that we use a strange way to add the fraction. So ultimately, we arrive at the fraction right here, 13 over 24, which is the same as the previous fraction that we mentioned right here at the top. So now, this video we try to do another example to get you familiar with such a amazing way to get back the original fraction. So please look at the following picture. So please look at this continued fraction decomposition of 67 over 24 here. And we've done this example already in the previous video. Please go back to that if you forget how to get it. So anyway, in this example, we start with the integral component 2. So to work in the previous way, we start with the line 1 over 0. And the next number should not be 0 over 1 like the previous example, because now you basically have integral component 2 here. So the way we do it of this point is 2 over 1. It represents that we actually start with the integral component 2 here. So now that's the first line. And the second line, obviously you need to follow the previous way of working, because this number is 1 in the code of the continued fraction. So it means that we need to step over just by one step to get the next number by the addition of these two numbers in a strange way I did before, and you get that is equal to 3 over 1. I hope you remember why, because just like the last class, we did the addition of fraction in such a strange way, and that's why I arrived at this number 3 over 1 here. And the next couple of steps are very similar to the previous case. That you need to look at the next number 3, and 3 means that you need to do 1, 2, 3, 3 steps to arrive at the new number here. I believe you are more familiar with it now. And first, let's get this number first. This number, you need to add these two updated fraction in a strange way I did before. So you go to 5 over 2 here, and the next number becomes the addition of these two numbers. So you get that is equal to 8 over 3 here. And now this number naturally becomes 11 over 4. Okay, so let's go to the next step. It's only one step here, so which means you just need to do one step of calculation. And now you get that it becomes the addition of these two fractions here. So you get the fraction 14 over 5 here. So now the last step to do is that you need to do 4 steps of changes, which means you need to do it like that to get the final number. So if all your calculations are correct, you should be able to arrive at 67 over 24 here. Okay, so let's try your luck. Just follow the rules here. This number should be the addition of these two numbers. So you get that this number becomes 25 over 9, and the next number we got 37 over 14, and the next number, which naturally becomes 53 over 19, and the next number, you need to add these two numbers in a strange way. So you get that the last number is the same as the numerator is 53 plus 14, which is 67, and the denominator becomes the addition of 5 and 19, so which is 24. So now I successfully illustrated this method. You can easily get the fraction of the continued fraction decomposition just by reading the code given in the continued fraction decomposition, and using such a strange way to deduce the fraction. So why is it important to do this step? So first of all, I hope you are familiar with such a way of working, and now I try to talk about something more conceptual. Why do we have to talk about such a step here? So let me explain a little bit in this video. So now the thing for you to do is please keep track of the numbers. Let's start with this one, 2, 3, 4, 5. So let me copy down these 5 numbers in a straight sequence. So now basically I copy down the sequence of numbers that we get in the previous picture. So please note that numerically speaking, we arrive at such a sequence that approach the original fraction we talk about, which is the fraction 67 over 24 here. And another amazing thing to notice is that such an approaching sequence, you can call it an approximation of the original fraction, actually approximated in a way that we start with a number less than it, and then the next number is bigger than the fraction. The next number again is smaller than the fraction, but obviously it gets a lot closer to the original fraction, and the next number again it gets much more closer to the fraction again, but this number becomes bigger than it again. So please let me emphasize it again. It's smaller, bigger, smaller, bigger. And the interesting fact is that such a pattern keeps continuing all time, so which means that we actually arrive at an approximation of the original fraction by using the numbers that we get in the previous picture. And it's actually quite amazing that such a pattern of approximating the original fraction actually do it in an alternative pattern, that if we start with a smaller number, it will get bigger and then smaller and bigger and smaller again back to the original fraction. So that's the amazing part here, and it's actually always true. So at the end of this video, I give you an example. Please try the following as an exercise for yourself, as a practice. So for such a fraction, the first thing to do, please, first let's write down the continued fraction of such a fraction given here, and the second step, I want you to do the previous kind of zigzag path like that to arrive at the original fraction 101/31, and please do it carefully. You should be able to do it. And the last step here, I want you to pick out the fraction you get inside the zigzag path and write it down as a pattern here, and verify that such a pattern actually gives you an alternating approximation, like smaller, bigger, and so on. Ultimately, this pattern can be used to approximate the number 101/31. And anyway, please do this exercise to familiar yourself of this way of working out the whole thing here. And that's the end of this video. Thank you everybody.